Understanding route redistribution concepts. Route redistribution is all about taking the routes from one routing protocol, let's just say EIGRP with all its happy WAN links and LAN links and servers and clients and everything else in this portion of the network, and distributing it into another routing protocol, let's just say RIP. With its happy WAN links and LAN links and all that kind of stuff. That's really all it is, taking some or all of the networks in each system and sending them into each other, so I can see the RIP routes in EIGRP and vice versa. So before we go any further with this concept, you have to ask the question, why would we do this? Because frankly, it's usually a bad idea. Because EIGRP is meant to talk EIGRP and RIP is meant to talk RIP. I mean, think of it this way. RIP is finding the best way around the network by what? Hop count, right? So it's saying, okay, this is 2 hops away. EIGRP is finding the best way around the networks using bandwidth, delay, reliability, loading, and, well, you say MTU because it's what you have to memorize, but it's not actually used in the metric calculation. So the question is, how do you translate from this metric down to this metric? Well, the fact is you don't. You just make it up. When you send the 10 network, 10.1.0.0 down here to RIP, you just say, you know what, that sounds like it's going to be 5 hops away. Is it? No, you just made it up. It's called the seed metric because they're totally incompatible. So you lose a lot of visibility when you do this. So the question is why, right? Well, you got the politics of networking. Maybe you got IT group 1 and IT group 2. They just don't get along. They're throwing tomatoes at each other, and so they divide. One runs EIGRP, one runs RIP. And believe it or not, that happens more often than you may know. Conversion, meaning maybe these guys got fired because they're like, what are you doing running RIP? And so they're all out of there, and so you're in the interim between converting this, or maybe there's a merge of 2 companies together. Or maybe you've got vendor selection to where you want all Cisco routers, and so you're slowly migrating away from RIP to a proprietary protocol, EIGRP, or vice versa. Maybe you're like, you know what, no more proprietary stuff, we're going to industry standard over, so you've got this interim while you're slowly converting the whole network. Or maybe you got application and business requirements. Maybe you've got something like, for instance, I have seen a comeback of mainframes where mainframes are coming back into the network, and sometimes these things run RIP. They don't have a default gateway, very, very old devices, and they receive their routes from the system using RIP, so we take all of our EIGRP stuff and redistribute it so the mainframe knows how to get around the network. Next step, how do you redistribute? Well, believe it or not, the how is actually really simple. It's the ramifications of that how that you have to be aware of. We'll talk about that more on the next slide. But let's just say we've got this topology, 3 routing protocols. In order to do redistribution, you go, and I'll say this slowly, into the routing protocol you want to redistribute into. So if I want to send routes from EIGRP into RIP, I go into this router and I type in router RIP, right? The protocol I want to go into. And then I type in the command redistribute EIGRP, which now sends the EIGRP routes into RIP. If I want to send into OSPF, I would go into this router or this router, and I would type in router OSPF, the one I want to go into. And I would type in redistribute RIP on this router. Or up here, I would type in redistribute EIGRP to send the EIGRP routes into that network. So that's the process. Now, there is something to be aware of, and that is the seed metric, the one that I was just telling you about on the other slide. You have to specify, or I don't want to say have to, but in many cases you have to specify what the default metric is. If I just go into this router right here and I type in router RIP redistribute EIGRP, it'll do it, but the problem is the default metric for EIGRP is infinite. Meaning the first router to receive those networks will be like, oh, well, the cost is too high on these things, I'm going to drop them, they must be invalid. Which just means that if I'm redistributing EIGRP into anything, I have to specify on EIGRP what the metric is. Just, I mean, again, make it up. Just say it's 1,000 or the bandwidth is this and the delay is this. It actually walks you through each thing. We'll see the configuration in another nugget. The only one that's not that way is OSPF. OSPF, if I just say I want to redistribute into OSPF, the default cost is 20. I'm sure there was some rhyme or reason to that when they picked it, but if I don't specify, if I go into router OSPF and type in redistribute RIP right there, all these RIP routes are going to show up in the OSPF routing table, starting off with a metric of 20 as they leave that router. If route redistribution is that easy to do, then why is it not a CCNA topic? Well, because it can blow up your network. Let me show you how. Let me show you how to blow up your network. Let's start with routing loops. Essentially, routing loops is where you redistribute into the system, and you redistribute and redistribute, and you end up having networks that go round and round and round and round and round and round. Essentially, this guy's like, oh, you're the best. Oh, no, you're the best. Oh, no, you're the best. Now, in a network this small, it's actually hard to cause a routing loop because, I mean, let's just say this is network X, right? And you send it up here and then down here. Well, when network X returns, this router's like, well, what are you talking about? I don't believe you because I'm connected to network X, so I'm going to invalidate that route. So there are built-in systems to try and stop routing loops, but you get a network that's big, totally can happen. And I mean, immediately you start seeing networks go down when you do that. That's the blow up the network situation. Suboptimal routing can happen much easier in a redistribution case. Just case in point, again, let's just say this is network X. I redistribute network X into EIGRP. Maybe that's running BGP down here or something else, right? So I redistribute that into EIGRP. Well, EIGRP actually has two administrative distances. Remember administrative distance, how believable is the route? 90 is what everybody knows for EIGRP. That is for internal EIGRP routes that are used inside of the system. Ones that have been redistributed, I keep doing that, is actually 170. That's an external EIGRP route. So we've got 170 coming up here, and we say, okay, well, I want to redistribute that route into OSPF. So network X now flies up here. Now, let me ask you, what is the administrative distance of OSPF? 110, right? For external and internal routes. So network X comes along over here, or man, rough times, right? Budget cuts, 14.4K modem. This guy receives network X. Okay, hold the phone, right? We sent network X up both directions. It's got an administrative distance of 170, right? This guy just got a network X from OSPF, which has an administrative distance of 110. Now, above the metric, administrative distance is king. It's going to always believe administrative distance before it even looks at how good a route is. And this router right here is like, oh, bing, 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 bing. I believe this is the best way to get to network X because 110 beats 170. Okay, I'm going this way to reach that route. That's our suboptimal routing. We're going through the 14.4K modem when we've got a 10 gigabit per second connection. That's why they bought this, is they spent all their money right here. And it's not using the 10 gigabit per second connection because of that suboptimal routing case. Now, can you fix it? Totally. I mean, you can fix any redistribution issue. Matter of fact, oh my goodness, if you want to know how do I get a CCNA or you already have one, right? I mean, CCIE master redistribution. That is what really most of, well, I don't want to say most, but a lot of the CCIE lab is. You get this big old map, and you got all these routers, and all that you end up, I mean, they just have you confuse yourself in the CCIE by redistributing from RIP to BGP to OSPF to EIGRP and back into RIP, and then redistribute this way and that way and every which way. And they're like, okay, now that you've followed our instructions and redistribute everywhere and the network's on fire, now fix it. So how do you fix it? Well, there's a few things that you can do, and I'm just going to hit a few of the high points right here. First thing is you can tweak the administrative distance. Like, for example, I said, you know, this problem happened because OSPF was more believable than the external EIGRP routes. Well, is there anything to say that as we redistribute that route into this system, we can't tweak the administrative distance lower, either right here, or tweak OSPF to be higher? Or maybe, matter of fact, OSPF allows you to specify an external OSPF route administrative distance, so why not do that? Just say, well, those ones will be 190. You know, make them not as believable if I redistribute EIGRP into OSPF, and then this guy's like, oh, you know what, these aren't that good. I'm going to go direct down here rather than going across this 14.4K LAN. Or maybe you start doing something called route tagging. Route tagging is so awesome. By the way, if you're in the CCIE, that is my totally preferred way of doing this because it's just so clean. So check out route tagging. You actually, let me just erase this little section of it. Route tagging means as I send routes into OSPF or maybe into EIGRP, I actually color them. When you do redistribution, you can say, I want to tag the EIGRP routes and just put a label of 50 on them, right? And by the way, a tag is just a number. It's like between 1 and 4 billion. So, I mean, just some huge range, right? So I say all these EIGRP routes going into OSPF, I want to tag. I just think of like coloring them. Like, let's say we've got that network X. There's network X. Color it red. There's our network X, right? And so as you go through, you can actually put a filter on these routes, and you can say, you know what, OSPF routes, tag them with 50 coming in, and then put a wall. It's a firewall for routing protocols. Do not allow 50 back out. right? And so anything that comes in, he's like, hi, I'm Network X, I'm colored with 50. And he comes down here, he's like, bam, you're dead, Network X, you cannot pass this line. And you do the same thing the other way. As you send OSPF routes into EIGRP, you say, all right, well, these are going to be tagged as 20. And then you put the wool the other way. You say, okay, 20 routes do not pass. I don't know why I go like Lord of the Rings, you know, spear on the ground, you shall not pass. Anyway, so that's tagging. Or you can use something like a prefix list. I'll put PL or AL, prefix list or access list. By the way, prefix lists are just fun. Prefix list is a way that instead of tagging these routes, you can just say, you know what, I know the routes. It's going to be 192.168.1.0/24 and 2.0 and 3.0/24. Those are going to be the ones that I allow through and do not allow those past. And that's a prefix list. The fun part about prefix lists is you can actually use CIDR notation. That's a little slash this, and you can do range. I mean, they're totally confusing. I'm going to do a nugget just on prefix lists. They're totally confusing when you first see them. And then when you get them, it's kind of like subnetting. You're like, wow, that's pretty cool. Or access lists. We all know access lists, and that's where we can just use wildcard mask and say these routes are allowed in. Again, I'm just giving you probably 3 of the most common methods. There's probably about 5 or 6 methods total that you can use. But the big thing that I want to talk about in this nugget is just there can be issues. You can't just go in and redistribute with your eyes closed and hope it works, because chances are good you can cause some major issues in the system that you need to go in and intentionally use these tools to fix. Well, now you've got the concept of what redistribution is and some of the issues that you can encounter when doing it. I hope this has been informative for you, and I'd like to thank you for viewing.